Ionic compounds, part 2, metals and polyatomic ions. This is Science 10, Chemical Reactions, video 4. So you can find your polyatomic ions on your handout sheet, and they're right here. And we also have our cations, which are our metals, that are right down here. Okay? You can find them on the other side with our polyatomics are here. And our metals would be our lithium, and all these would be metals that would be considered metals. But really only looking at these ones. Okay? Metals and polyatomic ions give us a metal and a polyatomic ion. Calcium carbonate would be an example of that. So calcium is Ca, and it has a charge of +2. Carbonate we can find on the sheet, and it's CO3 -2. Now, since it's a 1-to-1 ratio, I can just write Ca CO3 because I have +2 -2, which makes 0. Lithium nitrate is another example. So lithium is my metal, nitrate is my polyatomic ion. So lithium is Li +1. Nitrate is NO3 -1. Again, they're balanced, +1, -1, so I can just write Li NO3. So, how do we do this? So here's the steps. First, we need to identify the charge of your metal and your polyatomic ion. So say I'm doing sodium and nitrate, so NO3. Well, I need to know the charge, so I can look on my cation list, and it's +1. And my NO3 is -1. Well, my overall charge right now is +1, -1. So, my correct formula, since it's a 1-to-1 ratio, is Na, NO3, and that's it. And then I could write the correct formula, word formula, which is sodium nitrate. Now remember, I can look right on that sheet that it's a handout of the representative periodic table of elements, and it tells me all the information I need. So let's do another example. Let's look at lithium and sulfate, so SO4. So I look on my sheet under my cations, and lithium is +1, and sulfate is -2. So they're not 0. I have -2 here, so I'm going to need +2 here. So that means I need 2 more. Okay? So I now can write Li2SO4. I also can write it out in words, lithium, sulfate. And again, I can get sulfate right from the sheet, and I can get lithium right from the sheet. So my sulfate is my polyatomic ion, and my lithium is my cation. Let's do another example. Let's look at calcium and hydroxide. So calcium is +2, hydroxide is -1. Well, which means I need more hydroxide. I actually need 2 more hydroxide. So I've got +2, and I need -2. But I can't just put the 2 there, because that would mean I just have CaOH2. I just have 2 hydrogen, which is wrong. I have 2 hydroxides, because the whole entire thing is worth -2, and I need 2 of the whole entire thing. So really, I need Ca bracket OH bracket 2. And that would be right. And what really comes down to it is here I have 1 Ca, 1 Ca. Here I would have 1 O, and here I have 2 O's, and that'd be oxygen. Here I have 1 H, or 2 H's, and here I have 2 H's. So my number count for my total atoms for the top one is only 4. But I need to have my number count to be 5. Okay, so it's really important that if I need more of my polyatomic ion, I need more of all of it. And that's why my brackets are so important. So my word formula would be calcium hydroxide. Again, I can get these right from the sheet. Okay, next we're going to look at boron and carbonate. So boron is +3 and carbonate is -2. So like we did today, we looked at blocks. So mind the drawings because it's freehand. So we need a +3. So if we remember from today, our +3 have 3 mountains. And our -2 had spots for 2 of those. So therefore, I need another B. And I need so that's 1 more, -2, -2, I need 1 more. -2. +3, +3. So I need to add up how many +3s, and my overall would be +6. My overall for my carbonate would be -6. So I've made 0, which is perfect. And now I know I need to have 2 boron, and I need to have 3 carbonate. And I need the brackets because I need 3 of the whole thing. So I need B2 bracket CO3 bracket 3, which would be correct. If I don't use brackets, I get B2 CO3 and another little 3. And this 3 doesn't work. Okay? So we consider this wrong. So the brackets distinguish that I have 3 of this. So this really equals CO3, CO3, and CO3. So I have 3 of those. And I can write that as boron carbonate. Now, I can go from the other direction. I can go from a word formula to the chemical formula. So let's do an example. So let's look at magnesium sulfate. So we have Mg, and that's plus 2 because it's in group 2. And I have sulfate, which is SO4 minus 2. So, since I just need 1 and 1, I'm positive 2, negative 2, therefore I equal 0. Therefore my formula is just MgSO4 because it's a 1-to-1 ratio. Okay, let's do another example. So we're going to look at boron again and carbonate. So boron is B, and it's plus 3. Carbonate, CO3, minus 2. So again, that means that I need 3. So that's plus 3, minus 2, means I need another minus 2. But I'm still not balanced, so I put another plus 3 in there. So that means I need 2 of these. Again, brackets because I need more than 1. And that gets me 3. So my formula is just B2 CO3 bracket 3.